guys, and welcome once more to this video into our YouTube channel. So in today's video, we're going to be solving the commodity examination pure marine mechanics paper 3 of June 2024. So in this question, we're going to be solving question 7 Romans 2 of that year. So in the subsequent video, we have already solved question 7 Romans 1, which was actually still on center of mass. In this Romans, we are going to be solving a question which is still on center of mass, but a little bit different as the Romans 1. Okay, yes. The question reads, given that the shaded area in the figure below is bounded by two curves, given by x equals y squared divided by a and y equals x squared divided by a, we are asked to show by integration that the x-coordinate of the centroid of the shaded area is 9 divided by 20a. Now let us look into the solution of this question. Now to get the x-coordinate of the centroid of the shaded area, we are simply going to use this formula, which says that what? X bar equals the integral from x1 to x2 of xy dx divided by the integral from x1 to x2 of y dx, where x1 and x2 correspond to the different bounds of the integral on the y-axis. Now, in this particular formula, we have to take note of the fact that this y, we have to obtain this y in the first place. But before doing that, we have to take note of the fact that this y, it doesn't correspond to either of these two curves. Okay, it actually corresponds to the difference of the two curves. That is the difference. That is the upper curve minus the lower curve is going to give us this value y here. So in the first place, let us first of all obtain the expression for y in this upper curve here, in this first curve here. That is from x equals y squared divided by a, we can obtain y from here. So y from this actually equals to plus or minus square root of xa. But since we are working on the positive x and y axis, we are simply going to consider the positive value here. That is square root of, that is plus positive square root of xa. Actually, but as I said, this y, it doesn't correspond to this y which is actually inside this formula of x bar. Neither this y bar, okay, that is this y bar doesn't also correspond. This y here, excuse me, it doesn't also correspond to this y. That it doesn't correspond to the lower, to the curve here. That is to the lower curve here, which is actually y equals x squared divided by a. But this y corresponds to the difference of these two curves. That is this value, that is square root of xa minus x squared divided by a. Okay, yes. So that is going to be the value of y. That is this y is actually the difference of this curve and this other curve here. But let us prove that for you guys to understand better, for you guys to understand better what I want to say by that. Now, if you come forward and try to represent this, that is, if we have something like this, if you come forward and represent it, that we are going to have something like this. They are having something like this, where the distance is the x bar, is where this point here is x1. This point here is x2, okay? Here is x1, here is x2, here is x1. Now, we know that from integration, if you want to find the area of a function, okay, the area of a function. Now, the first thing, or the first notion which we usually have in mind is that what? That if you consider for the, if you call this function, for example, this curve here, if you call this curve f, if you call this curve f, and we call this other curve here g. Now, for us to get for us to get the integral of this, that's for us to get the area of this shaded portion, we are simply going to have the difference, that's the integral of the difference of these two functions. Why? Because if we come forward and want to get the integral first of this function f, so of this curve f, what are we going to have? That if you come and represent it, let us represent it with a different color. That is for this first curve here, okay? For this first curve, that is the area bounded. That's the area bounded by this first curve is going to be the integral of this function from x1 to x2. Now, what about the area bounded by this second curve g here? Let us indicate that as well. That is the area bounded by this second curve here is going to be this one. These green lines as such is going to be the area. That is the area bounded by this curve here on this x-axis is going to be the integral of this second curve from x1 to x2. Now remember, since we want this interior portion, that is, since we want this area here, the area of this interior portion here, what are we going to do? We are simply going to consider the fact that that area, that is the area of that portion, that is that area is simply going to correspond to what? That area is simply going to correspond, that is, this area here, I will call it A. This area A is going to be equal to what? The integral of this function. That is the integral of this curve here. That is of f okay, from x1 to x2, are we there? Then minus the integral of the function d, obviously the x from x1 to x2, from which we can therefore further simplify that, we can group them together and obtain finally that area to be equal to the integral, okay, of f minus g, obviously from x1 to x2 dx. Are we there? For this particular case, that if you consider this axis to be the x axis so far, okay, so you clearly agree with me that it's simply like the same thing for this case. The same thing we are going to be doing here. It's actually the same thing, nothing is different there. That is, to get this y is actually going to correspond to this f minus g value. F here will correspond to the upper curve and g will correspond to the lower curve. So this y here is going to correspond to the difference of these two curves, this other one and this other one. So that is the notion which we have to take note of for us to solve this question here. Very, very important. So that is it. So that's how we are going to proceed to get that x bar value, knowing already the value of y, and x there doesn't change, it remains x, and from which we can therefore proceed with our solving. That is it. Nice. So as I said, actually that this y here, this y is going to correspond to the difference of the two curves, where the first curve is what we have obtained by simply making what is called the formula here, which is the upper curve, take note, which corresponded to f here, and the second curve, which is the lower curve here, is going to correspond exactly to x squared divided by a. So the difference between the two corresponds actually to the value of y here. Very, very important. Then the x. Now x1 here corresponds to 0. Actually, okay, x here, x1 here corresponds to 0 because in the equation the diagram was given as such. So we consider this one because all the distance a automatically here becomes the origin of our reference automatically. Okay, so x is going to vary from 0 to this a value. Are we there? That is, x1 is going to be 0 and x2 is going to be a. Okay, then all this divided by the integral from 0 to 1 of y to x, where y is actually the difference of the two functions so far. So from which, further simplifying, that is, if you introducing this x inside that's multiplying x in the numerator value, okay, and separating terms, we are going to have x bar to be equal to square root of a, then have the integral from 0 to a of x raised to the power 3 and a half, the x y 3 and a half, because here we have x. So if you factor out square root of a from here, we are going to have square root of x, then times x, we are going to have 1 plus a half, actually give us 3 and a half dx, then minus 1 divided by a times integral from 0 to a of x cubed, because we multiply x, we are going to have x cubed dx, then divided by the square root of a times the integral from 0 to a of x raised to the power a half, because here we are simply going to be left with the square root of x, then dx, minus 1 divided by a times the integral from 0 to a of x squared dx. Okay, yes, on which further simplifying, that is integrating, we are going to have what? Here we are going to have square root of a, that is 2 times square root of a divided by 5, then times x raised to the power 5 divided by 2, then from 0 to a. Why? Because if you integrate this x raised to the power 3 and a half, we are going to have x raised to the power 3 and a half, then plus 1, which actually give us automatically 5 divided by 2. Okay, then minus here the same thing, that is 3 plus 1, that if you integrate this one, you're going to have x to the power 4 divided by 4. If you bring the 4 outside, we're going to have minus 1 divided by 4a, then times x to the power 4 from 0 to a, to put in the amounts of integration, then divided by, similarly here we are going to have what? Here we are going to have square root of, that is 2 times square root of a divided by 3. Why? Because if you integrate this x raised to the power a half, we are going to have a half plus 1, we give us 3 and a half. Okay, we give us x to the power 3 and a half divided by 3 and a half, which is the same thing this is the same thing which we did for the numerator part. Okay, yes. Take note here, we will take note of it. That is, here was 5 divided by, that is, if we integrate x to the power 3 and a half, we are going to have x to the power 5 divided by 2, then divided by 5 divided by 2. Okay, take note, very important. And similarly, the same thing which we are doing here, that is, if you want to integrate x to the power a half, we are going to have x to the power 3 and a half divided by 3 and a half. But bringing the 3 and a half outside here, we are simply going to have 2 square root of a divided by 3 times x to the power 3 and a half from 0 to a. for the integral, that for when we integrate this part, then minus, if we integrate x squared with respect to x, we are going to have x raised to the power 2 plus 1, we actually x raised to the power 3, then divided by 3, bring the creator outside, we are going to have negative minus 1 divided by 3a, then times x raised to the power 3, interval variable from 0 to a, from which, further simplifying, we are going to get what that is, putting the bound, that's the upper bound minus lower bound, we are going to get 2 square root of a divided by 5, then times a raised to the power 5 divided by 2, because if you put 0 here to be the lower, if you put the lower bound, you're simply going to get 0, then minus 1 divided by 4a, then times a raised to the power 4 divided by 2 square root of a divided by 3, then times a raised to the power 3 and a half, then minus 1 divided by 3a times a raised to the power 3 automatically. From which, further simplifying, that is, if you multiply, if you have here we have square root of a, then square root of a is actually a raised to the power a half, then times a raised to the power 5 divided by 6, we get a, you simply get a cube here. Okay, yes, then times 2 feet, then minus 1 factor times this a is going to cancel 1a here, that's you're going to have minus 1 divided by 4, then that's a raised to the power 3, then divided by 2, divided by all divided by 2/3 times a squared. Why? Because if you have a raised to the power a half, a raised to the power a half times a raised to the power 3 and a half, that's simply going to get a raised to the power 4 and a half, and it actually give us a squared. Then minus 1/3 times a squared. Why? Because 1a here, this is going to cancel 1a from this a cube. From which, further simplifying, that's doing the LCM here, we are going to get what? The LCM, the numerator, we are going to have 20. 20 divided by 5 give us 4, then 4 times 2 give us 8, so we are going to have 8 a cube, then minus 5 a cube. Okay, we give us 3 a cube divided by 20, then all divided by what? All divided by, since I have the common denominator, we are simply going to make the difference, that we are going to simply going to do the operation that the numerator value, that is 2a squared minus a squared, will actually give us a squared all divided by 3. For which, further simplifying, we get the x bar, which actually the x coordinate of the centroid of the shaded area, to be equals to 9a divided by 20, which is actually what we require for us to prove in the Roman 2 of the equation.